All right, in this video we want to look at vectors in 3 dimensions. Vectors in 3 dimensions. And so I will certainly assume you have a pretty good knowledge of 2-dimensional vectors already, and a decent knowledge of 3-dimensional coordinate systems. So when we look at vectors in 3 dimensions, they're represented a couple different ways that we'll look at. So a couple different representations, ways to write them. One way is your standard component form. And that's where you use angle brackets, and then you put the 3 components of the vector. So a 3D vector has an x component, a y component, and a z component. Has a component in each of these 3 directions, okay? So that's one way to represent them. Another way to represent them is using the unit vectors I, j, and k now. So if you recall from 2-dimensional vectors, the I vector points in the x direction, and that's still true. So the I vector is the unit vector 1, 0, 0 now in 3 dimensions. The j vector points in the positive y direction, so that's 0, 1, 0. And the k vector points in the positive z direction. This guy's new, so it's 0, 0, 1. All right, so I don't want you to confuse this j hat with the j hat in 2 dimensions, because in 2 dimensions it's just 0, 1. So it's still, you can still put that in 3 dimensions. It still points 1 unit in the y direction, but we need to tack on this 0 z component, since vectors in 3 dimensions have 3 components. All right. So how do you write vectors using ijk? Well, you put the x component next to I hat plus, not a comma, no angle brackets, y times j hat, your y coordinate, your y component times j hat, plus your z component times the unit vector k hat. So those are the 2 standard ways to represent vectors in 3 dimensions. All right. Now let's look at how to visualize vectors in 3 dimensions, how to draw them, which is kind of fun, maybe a little bit challenging for some of you. Certainly was for me the first time I tried it. So let's say I want to draw the vector. And this won't be perfect, but I'll label to help overcome any measuring deficiencies. Let's say I want to draw the vector 2, 3, 4. All right, so I want to draw that vector. Now, the problem with this is I need to draw this vector giving it a 3-dimensional perspective on a 2-dimensional board. So it can be a bit challenging. And so what we're going to do is we're going to assume that the positive x direction is coming forward out of the board. So this means the x means we're going to move forward 2 from our starting point. The 3 means the y component is 3, so we're going to move to the right, positive 3. If it were negative 3, we would move left. If it were negative 2, we'd move backward, okay? Because x and y move those directions. Positive 4 in the z direction means move up 4, okay? So that's what we're going to do. So we have to pick an origin, all right? So I'm going to pick an origin that I need to come forward, right, and up. So maybe I'll pick my initial point for my vector down here. So I'll label that with, let's call that 0. Maybe that's the origin. That's the initial point of our 3-dimensional vector. And from there, I'm going to move forward 2 units. So forward direction is at an angle out of the board. So anytime I move in that direction, I need to be parallel to whatever my reference line is going to be here. So I'm going to move forward 2 units. So I'll just kind of remember that that's 2 units. I could label it here if I wanted. Okay? 0 is the origin. Maybe let's indicate that with a different color so we don't get things mixed up here. So 0, or the letter O, whichever you prefer, is the origin. So I moved forward 2. Now from there I need to move right 3. So I need to move right. Moving right is pretty easy. 3 units. So let's call that 3. And at this point, what I could do is I could draw parallel lines to these of the same length, and I can establish a perspective. So for example, I could draw another line coming to the right 3 units from here, parallel to this line that has about the same length. I'm not going to label it again. I will assume they have the same length. And then I can draw another line over here that is parallel to my forward direction there. All right, so now I have a little bit of perspective. Think of this as being a rectangular floor tilted back. So these are all right angles. Now what I need to do is I need to go up 4 units. All right, so let's track what we did. We started here at 0, moved forward 2, right 3, and now I'm here. So let's move up 4 from there. So moving up 4 from there, let's label that as 4. My vector is going to terminate right there. Maybe let's label that with something like a T for terminate. So I know my vector is going to start at the origin, it's going to terminate there. But I need to finish drawing my picture, okay? So I need to create a box out of these 3 dimensions. So I need to replicate this vertical 4 measurement on all 4 corners. So let's say that that's 4, something like this. This is 4, and maybe that's about 4. So don't laugh at my picture. I'm not using a straight edge or anything. But if you use your imagination, you can imagine that that's a rectangular box, a prism. So now I can finish it off by drawing my ceiling that matches my floor. So it's going to be the exact same shape as my floor, something like this. Okay, this takes practice. Now, look at all of these slanted lines. They all should be pretty much parallel. Doing that's going to help you tremendously. The right and up, the Y and the Z, those are pretty easy to draw. It's the X that's difficult because that's slanted. But that's our box. This box contains our vector. It now gives us a 3-dimensional perspective on our vector, 2, 3, 4. So where's the vector? Well, the vector starts at the origin and it terminates up here in this corner. So it looks something like this. Maybe that purple doesn't work too well. Let's try a different one. I don't know how well you can see that. That one's better. So that is our vector. And so you can tell from this diagram, well, that vector starts here, comes forward 2, moves right 3, and goes up 4. And so when we contain our 3-dimensional vectors in this room, let's call it a rectangular room of some kind, you can tell it goes from one bottom corner to one top corner across the room in this particular case. So that's how you can draw a 3-dimensional vector. All right, let's try another one. Let's maybe throw a negative into the mix. Maybe a couple negatives. So let's say this time we want to draw the vector. I don't want the numbers to be too small so that we have a big enough picture to work off of. Let's say we have negative 3i hat minus 5j hat plus 6k hat. Okay? So I'm going to have a box that's 3 by 5 by 6. You can already imagine that. But in particular, the negative 3 means we need to go 3 back. So 3 back. The negative 5 in the y direction means we need to go 5 left. And the 6 in the z direction means we need to go 6 up. So I'm going to pick my origin, and I have to go back, left, and up. So I'm going to give myself plenty of room. Maybe my origin is down here. So I'll label that with an O just so I can keep track of things, okay? Here's my origin. Now I need to go 3 units back. Now forward, if you think of the marker moving in the x direction, forward is out of the board, so backwards is this way. So I'm going to start here, and I'll go backwards at an angle, and I'll label that as 3. just to keep track of it. And then I need to go left 5. So again, these measurements aren't precise. I'm labeling them so that we know what they are. And then I'll complete my rectangle by drawing parallel lines the best that I can freehand, okay? So there's what we start with. So now, let's go back. I start at my origin, I go 3 back, 5 left, and then I need to go 6 up. If I were going 6 down, I'd go down from that corner. So this now is 6. And then to finish the box that will contain my vector, I will draw parallel lines to this exactly the same length. I say exactly, shouldn't have said that, but something close. Okay? And I'll kind of fix it as I finish it up and draw my ceiling, okay? So something like that. And again, if I go 3 back, 5 left, and 6 up, 3 back, 5 left, 6 up, this is the point at which my vector terminates. So now I can draw my vector. To be honest, most students get the box and then they forget, oh yeah, I need to draw my vector. So my vector starts at the origin and travels from this bottom corner up to this top corner that's in the back. So that's the vector, negative 3i minus 5j plus 6k. Okay, so that's all great if none of the coordinates, none of the components are 0. So sometimes the easier vectors can be tricky. So let's take a look at a 3-dimensional vector with 0 as one of the components. And this will be the last example. So let's say I want to draw, 6, 0, negative 8. We haven't seen a negative z component yet. So if I want to draw that, then I need to go 6 forward, meaning coming out of the board. You could write 6 out. I need to go 0 left to right. I won't write left to right. And then I need to go 8 in the negative 8 in the z direction, so that's 8 down. Okay? So now I pick my origin. I need to come forward and down. So I'll pick my origin up here this time. Forward looks like this, so 6 forward looks like this maybe. Perhaps I don't like that angle for some reason. So there's 6 forward, and then I need to go 0 left to right, so all I do is I go down 8. Okay, so this might be tricky, but still if you draw your 2 parallel lines at this point, you get something that looks kind of like this, and that's it. If you think about it, it's a plane, it's a flat surface cutting through this whiteboard going into the wall. So the vector starts here, it terminates down here. You don't get a box now. You get a rectangle that contains your vector. And so the vector, in this case, starts in this corner of the rectangle and runs down to that corner of the rectangle. So it's contained within this plane that runs perpendicular to my wall here. Okay, so if you can visualize that. Again, all of these angles are right angles in 3 dimensions. Okay, so that's drawing vectors in 3 dimensions. Sometimes you don't have to do that. Most of the time you don't to work with them, but it's really good to be able to visualize what a 3-dimensional vector looks like and what the components mean. So I hope you enjoyed the video.